In this lesson, I'm going to explain to you what domain and range are. These are really important concepts for the course and for future courses that you're going to do in math. Before we do that, I just want to do a reminder of some different number sets, because we're going to use number sets when we're identifying domain and range. Natural numbers are numbers that you can count on your fingers and toes. There's no decimals. They start at 1, so it's 1, 2, 3. It's like when you're a child and you first learn to count and someone put some Cheerios in front of you and you went 1, 2, 3, and so on. You never thought about the concept of half a Cheerio or 3/4 of a Cheerio. Whole numbers are the same as natural numbers, but we add 0 as well. The concept of 0 actually isn't that intuitive, and so we have to be a little bit more sophisticated before we understand what 0 means. 0 just means the absence of numbers or absence of objects. And in the history of math, whole numbers definitely came later. 0 was not really understood until later in human history. Integers are still no decimals or fractions, but they involve negative numbers. They can go to negative infinity up to positive infinity, but we do not have fractions or decimals involved. And a good example for integers I like to think of is money, right? Whole negative, positive amounts of money. I owe you $10, that's negative 10. You owe me $20, that's positive 10, and so on. Rational numbers can be written as a fraction. Okay, so anything that can be written as a fraction, and I'm going to put the emphasis on the word can because it doesn't have to be written as a fraction, is a rational number. So some examples of things that aren't written as fractions but could be would be the number 2 or any whole number, or a decimal that ends like 2.5. I could write that as a fraction. I could write that as 5/2 or various other versions. Or decimals that repeat, like 2.3 repeating. That would be the same as 2 1/3 if I wanted to think of it as a mixed number. And then once I've got it as a mixed number, 2 1/3, I could change that to 7/3. So again, anything that either is a whole number, is a terminating decimal, or is a repeating decimal can be written as a fraction. That makes it rational. Irrational numbers are just the numbers that aren't rational, so they can't be written as a fraction. And so the most famous one of the irrational numbers is pi, but anything that just goes on without showing any signs of repeating, like pi or like this number I just invented here, would be irrational. There's no way for me to make this into a fraction. Real numbers, that's the one we really want to get to. Real numbers are basically all numbers we can think of. It's rational and irrational numbers taken together. So basically anything we can think of. Believe it or not, there are other number sets like imaginary numbers. For example, if I take the square root of -1, that would be an imaginary number because it's something I can't actually do. But if you get into higher level math, they do talk about things like imaginary numbers, and they're not real. But we're only going to deal with real numbers, ones that actually make sense in the real world to us. All right, so here is what we need to know about domain and range. Once you let me just say ahead of time, once you wrap your head around these concepts and work with them, they'll become very easy. Until you do that, they're going to seem very complicated. So give me your full attention and go over this as many times as you need. Rewind this video as many times as you need until you're absolutely clear on what I'm saying. It's easiest to see on a graph. So let's look at this graph here. We know that a Cartesian plane is broken down into x values and y values. And every point on a graph has its own xy coordinate, right? So that one that I just chose would be the point 1, 2. Domain simply means what are the x values that are possible for a given function. So this is a function. This graph is a function. And we can assume that it's going on forever in both directions because that's just what we're going to do. So I'm going to put some arrows on the end. And so it goes on forever in both directions. What are the possible x values for this function? Well, clearly, as far as what we can see on this graph goes, we can see every x value, every point on this x-axis for the part we can see between -3 and 3 has a y value associated with it, right? Pick any point, pick this point, and yeah, there's a y value associated with it. Pick a point here, y value. Pick a point here, y value, right? So all of the points between -3 and 3 are represented. Since it goes on forever, we can use our imagination and say, okay, well, definitely, there aren't going to be any points on this graph, again, this line here that I'm looking at. And so again, this is when I talk about the graph, I'm talking about this line here. There's no values where I won't be able to find an x value that has a y value on this line. I can go to positive infinity, I can go to negative infinity, basically any number I can think of. Well, what do I represent by any number? I use real numbers to represent any number because they're all rational, all irrational together. So in this case, since this graph can go all the way to positive infinity and negative infinity and anything in between on the x-axis, we'd say the domain is all real numbers. And that's what this paragraph here is talking about. So I'm just going to skip to the part where we're actually writing it. This is how we write the domain. D for domain equals squiggly brackets, which means set notation, so the set of x, and this thing that looks like an E means is a member of, or let's just say it that way, is a member of, and then this R is real numbers. So maybe up here I should, so if I just make an R with 2 uprights, 2 vertical lines, that's pretty much the same as what they put in, that I've highlighted in those brackets. So it's just saying that the domain is a member of real numbers. In other words, the domain is all real numbers is another way of reading this. And that's what it actually says right underneath. Domain belongs to the set of all real numbers. So it's all real numbers. There's no exceptions. Be clear on this. Be really clear on what I'm saying about domain before you go on, because if that clicks into place, everything else will. Okay? Assuming you're clear on that, then let's go on and see what range is. Range is simply the exact same idea as domain, except on the vertical scale on the y-axis. Remember, every ordered pair has an xy coordinate. And again, if we look at this particular graph, this particular function, we can see that as far as what we can see on the grid goes, all y values are represented. I pick any y value, I'll find a corresponding point on the graph, right? So any y value, I'm just picking points, and you can see they all connect up with the graph. So that's identical to domain, except measured on the y-axis instead of the x-axis. And again, if we imagine this line going on forever in both directions, it's going to go up all the way to infinity, and there's never going to be any gaps in it. So all the y values are going to be represented. It's going to go down all the way to infinity, if that makes any sense. All the y values are going to be represented on that. So again, for this particular graph, the range is going to be all real numbers. There's going to be no numbers that aren't represented by the range, or in the range. So again, the range, how do I read this? The range is the set of y values such that y is a member of the set of real numbers. In other words, it's all real numbers. Okay, that's the most basic thing, but you'd be amazed at how many people fumble around with this for a while until they really get a full grasp of it. You're going to need to practice it. You're going to need to look at graphs and say, okay, what's the domain of this graph? What's the range of that graph? Until you've really wrapped your head around it. But once you do, you'll have it forever. Communication tip. Set notation can be used to describe domains and ranges. Well, we just used that. So this example up above, the domain and range were both all real numbers, but it's not always going to be the case. For example, here is a set that could be maybe the domain of something, and I would read this one. Well, here it says on the graph, it's written out for us, so let's go with their wording. The set of all x values, okay, the set of all x values, that's this part, that belong to the set of real numbers, okay, it includes that, such that x is greater than 0 and less or equal, greater than 0 and less or equal to 50. Awkward wording, but anyway, that's what this part here is saying. So in other words, just look at this part here. X is between 0 and 50, but pay attention to the greater than and less than signs. The less than sign between the 0 and the x is just a less than sign. So it doesn't have that line underneath it to include the equal to part. Whereas the less than sign between the x and the 50 does have the line underneath it. So it means that we're including the 50. So again, x is between those two numbers, right? So x is greater than 0, but not including 0, not equal to 0, up to and including 50, and anything in between, 1, 2, 3, 4, 5, 1.1, 1.11, whatever. Any number between 0 and 50, not including 0, but including 50. State the domain and range in each case. Okay, so sometimes we're given graphs, sometimes we're given equations, sometimes we're given tables. I can guarantee you that if we have a graph, that's always the easiest. And if we don't have a graph, it's certainly good to try and visualize what it looks like, what the function looks like. Y equals x squared, you may recall, looks like this. It's a parabola, and it has its vertex at the origin. It opens upwards. It's the most basic parabola there is. Look at the domain. Think about the x-axis. The points don't have to be on the x-axis, but think about the x-axis. What values of x are allowed? That's another way to say it. So imagine this graph going on forever. Yes, it's going upwards, but it's slightly going out as well. So if I go far enough out, I can get to any x value. There's no x values we're not going to get to on either side, positive or negative side. So there's no x values that aren't allowed. That's a good way to think about it. Ask yourself, are there any values that aren't allowed for the domain or for the range? Right now we're looking at the domain. There's no x values that aren't allowed. On the graph, we can see that it works for all of them. If we look at the equation, it also works. Pick any number you can think of and ask yourself, am I allowed to square it? Would I get an answer if I squared it? And the answer is yes, you can square any number. There's no restrictions on what you can square. So that's another way to check. The domain is all real numbers. The range, however, as we know, is what's measured on the y-axis. Are there any y values that aren't going to be allowed based on, especially looking at the graph here? Clearly, we can see that this function does not go into the negative values on the y-axis. So no negative values are going to be allowed for the range. They're just not represented, are they? So what is allowed? Well, it's all real numbers with a restriction. I usually use a line, but you could check the different formats like this one up here if you prefer. But anyway, so y is all real numbers, but there's a restriction. They have to be greater than or equal to 0. The vertex does touch 0 on the y-axis, so we'll include that. So I'll put this line here underneath to show that I'm including the 0, but it's greater than or equal to 0. That's my range. And again, if I think about it in terms of the equation, I can square any number I want, right, for x, but my answer will always be positive or 0. And that's why the range can never be a negative number. Y values that are negative won't work. If we look at a set of points, this function is represented strictly by this set of points. So this is my entire function, these 3 points. Here's my x values. Here's my y values. My domain is, of course, my x values. My range is, of course, my y values. So if I just go and look, all right, I got 1, 3, 5 as x values. That's it for my domain. Those are the only values that x can be if that's my function. My range can only be these numbers. You'll notice that the last number repeats the 1. There's no point in writing the 1 down twice. So I just wrote it down one time. 1, 2, 1 is just 1. Again, this notation, remember, think of these as x's, think of these as y's, and any arrow is going to give us an ordered pair. So my domain is going to be the specific x values that we can see. Well, I can see there's 1, 2, 3, 4. Those are all x values that are going to be parts of ordered pairs. And so that would be my domain. My range is going to be any y values that we use. But notice how I'm skipping over the 25 because we're not actually using it in this function. So I just use the 15, 20, and 30. For each relation, state the domain and range and whether the relation is a function or not. Okay, so again, graphs, often the easiest way to do it, so that makes it easy, and we're going to add in the part about just double checking whether we can recognize functions. So for this one, the domain, what x values are allowed? We can see it starts at -3 and it goes up by 1 until it gets to +3. Notice how it's not a solid line though, it's just the points. So there's no -2.5 in there. So I wouldn't do all real numbers. If it's just a list of particular numbers, I'm going to actually write them out as a list. So these are the actual x values that are allowed, and that's all they are. There's no other values allowed because, again, they're just points. It's not the numbers in between the points. For the range, the y values start at -2, right? And they go up to +4. So, but again, we're not doing the numbers in between points, just the specific numbers we can see. So, oh my goodness, there we go. Trying to get a blue pen. -2, -1, 0, 1, 2, 3, up to 4, without the points in between, which is why I've listed them. Here's a different parabola. Again, we can see the parabola. I'll come back and decide whether things are functions or not after I've done all the domains and ranges. So here's a parabola. We've already seen that parabolas are pretty much the x values, anything's allowable. So it's all real numbers. If you imagine extending this graph forever to the right and left, there's no x values that would be excluded. However, the range is definitely below +3, right? Does it include +3? Yeah, it does, because the vertex seems to be touching +3. So y is a member of the set of real numbers. Y is, I keep writing x, y is less than or equal to 3. Again, that's the highest y value. The highest y value is the point, at the point 1, 3, but all I care about is the 3 part that it's below. And why am I not just listing points like I did in A part? Well, again, this is not a bunch of dots, right? A part was a bunch of dots. That's why I listed points. This one is a solid curve with all the numbers in between included. So that's why I'm using the XER or the YER and not just listing points. Now we got some tricky ones, or a tricky one. We have to really keep our eyes on the prize here. What's going on for the x's? Well, the lowest x value starts here about -5, and it goes all the way up to, I don't know, what would that be, 7 or 8, hard to tell. No, sorry, 12 or 13. I guess it's 12. Maybe not that hard. Maybe it's 11, actually, now that I'm reading the scale a bit more closely. Anyway, it goes up to there. That's all we have listed, right? So it's continuous. You know, as far as the x values go, there's no place between -5 and let's call it 11. where we don't have an x value represented. So the domain is all real numbers. But again, there's restrictions. There's a lower end. The lower end is -5. There's an upper end, which we're going to call 11. X is going to be in between them. As far as the greater than or less than signs, this is a less than sign. So I always use less than signs if X is in the middle. Okay, so always use the left, so where the alligator mouth points to the right. At -5, we got an open circle, which means that we're not including the -5. So it's X greater than -5. But at 11, we got a closed circle, right? This one here is a closed circle. We are including 11, and definitely I'd put the equal sign underneath. One way you can think about, is anything missing, is imagine that if you were to compress this graph down vertically, so compress it so that the whole graph was smushed up against the x-axis, what would you have? And if I do that, again, it would be a continuous line on the x-axis from -5 up to +11. As far as the range goes, now we're only looking on the y-axis. So what are the y values that are going to be acceptable? Well, if we, again, let's imagine that we're just crushing this graph up against the y-axis now, up against where I've highlighted in green. There's actually 2 points where it's going to touch the y-axis. If I do that, it's going to touch it at, it looks like about 6 and at about 2 maybe, right? Because we got these points here, like this point here, which would be 5, 6, and then another point here, which would be -5, 6. All the numbers on this line would have a y value of 6, wouldn't it? So that's going to be one of my points. That's one of my range values is 6. These ones here, that would be the point 5, let's say it's 2. And maybe this is the one that's 11, 2. They're all going to have the same y value as well. So 6, 2, maybe I should write them in numerical order from lowest to highest. So 2 and 6. But that's it. Every single point on those 2 lines has got a y value of 2 or 6. Nothing else is going to be allowed. The circle one, again, let's look at the edges. This has got the point, this is the point 5, 0. This is the point 0, 5, -5, 0, 0, -5. As far as the x values go, it only goes between -5 and +5. But it does include those ones. It seems to touch those, the -5 and +5. But it touches everything in between. X is all real numbers between -5 and +5. I recommend you do it like this. Do your limit, your lowest and highest numbers first, if there is a lowest and highest number, as there is in this case. Put the x in the middle, and then put your greater, or in this case, less than symbols in there. Both of them will have equal signs underneath. That's my domain. As far as the range goes, it also goes only between -5 on the y-axis and +5. But again, it is all the values in between. I can pick any value on the y-axis. For example, say I pick -2.5. There's definitely an x value that goes with it. There's another one. So in fact, there's 2. So there's no shortage of points in between -5 and +5 on the y-axis. And again, we're including the -5 and the +5. But beyond that, the points we don't hit any of those points. Okay, let's go back and quickly finish off whether it's a function or not. This is a function. It passes the vertical line test. This is a function. Again, passes the vertical line test. This one's also a function. Now, maybe a bit harder to see. Let me get rid of all this extra stuff here. But you may wonder about this place here, this point right here. But again, we have an open circle here, which means that they're not actually overlapping. It will pass the vertical line test. And this last one, most definitely not a function. Why not? Because it would fail the vertical line test in many, many different places.